So for a combinational logic or making a circuit, the first step is that we make a logic. We make a logic through a truth table. How this logic is made, that where where on the where in the line follower robot our robot should move. It should take a turn left or right. That all will be decided by a truth table. So a truth table, we are using four sensors which will detect the black or white surfaces. So following the black line, which is basically the work of a line follower robot, that black line will be detected by these sensors. So by particularly detecting a black line on the by each of these sensors, the the ICs which will control the motors, these motors will be turned on or off. That will decide whether it is moving forward or taking a turn left or right. So what are these zeros and ones? First of all, I will explain it. uh, on the black surface, if the sensor is detecting a black surface, it will give a zero as an output. And if the we are taking a zero as a black surface, and if it is white, it represents a white surface. It is one if it represents a white surface. So in case of motors, a zero represents a zero represent an off, and one represents on. So wherever we will use zero as, we will represent off motor. And if we say it's one one on the motors, it says that it is on, and the robot is moving forward. So let us explain uh, all of these 16 cases in a nutshell. So wherever this zero is detected, zero is written, it means that the sensor is detecting a black surface. So wherever it represents one, it means that it has detected a white surface. So while moving forward on the black line, if the motor is reached to a point, that is obviously the last case, where it reaches a black surface, a black strip, a black line horizontal, then the motor should stop, and the robot should not run. So the first and the fundamental case is basically if the robot is following a black line, it means that both the central sensors are on zeros, and the left and right sensors are on are ones. So it means that the robot is following a black line, and the other two sensors are detecting a white surface. So it tells the motor to keep moving. So the robot is moving in a straight line now. Now, one more fundamental case, that is all surfaces are white. So if it's not necessary that we say that the surfaces are white, so the motor should keep running. But it's basically for a case if it has left its line, so that so we are giving it a high, so that it somewhere finds that black line, and it then follows any of these 15 cases. So that is it for the truth table. So the next step in building a combinational logic or combinational circuit, we have to make an equation from which we will make a circuit. So from truth table, we will fill our KMF for left motor and right motor. So as we know how to make a K map, these are basically this is a 4 by 4 K map, 4 cross 4 K map, and wherever it gives a high, we have to fill it, and after that we will follow our method of making a function from kmap. So that all we know. So from that we have made an equation for left motor and for right motor. From the equation that we have obtained from a KMF, we can easily make a circuit. That is our choice whether we use AND or GET, or we use NAND representation, NAND implementation. We have used an AND or representation. So here we have four inputs as sensors. These are high and these are its low. This is a OR gate that is controlling all these, taking inputs from directly from its final equation. This is an AND gate. So in this way we have made a combinational circuit. So our theoretical work is now done. We will make this we will implement this circuit on our software. We are using Proteus as simulation software, and we will confirm its working, whether it works, whether it performs our required operation or not. The next and final step in in making a circuit is basically the PCB making, PCB fabric, in the software basically. So in Proteus, we have used our PCB design, PCB layout function to make this PCB from that schematic that we have already made. So these blue lines are actually the bottom copper, but due to the due to the crossing of lines, we have used upper copper, that in further in circuit we will be using as jumper wires. So these are the four sensors that will be connected on the PCB board. This is basically the voltage source, the power source. This is a voltage regulator, and OR IC and NOT IC and AND IC, and these two are the connections for motors, left motor and right motor. So the second stage we will be following in the combinational circuit making is the simulation of our circuit that we have made from KMAP, and the implementation of that circuit in Proteus, and seeing its simulation whether it works or not. So let us discuss what comes first. This is the battery source. So in a power source, which is fundamental, this is a simple connection, that is not that much important for, but we have made this for PCB plate to fix that battery in on our PCB. This is basically the connection that will be given from the battery as a power source. This is a voltage regulator, a 5 volt voltage regulator basically. This is necessary for the ICs, so that the ICs do not burn, because the cells we have made were 7.4 plus volts. So if we give all the power source directly to the ICs, it may burn. Okay, so these are the two motors, and these are the four sensors. These sensors are basically sensor left, sensor right, sensor center 1, and sensor center 2. So these will detect the black and white surfaces, and these are the two motors, motor left and motor right, and these will ensure the movement of that robot. Okay, these are basically the silk connections that we will use to give extra connections for the ICs, so that if any terminal burns, it should be available for us. So for 3D model, we have used the function of a Proteus software to make a 3D model from that uh, PCB, and we have used some options for making these connecting these tiles and all this. So uh, the PCB we have made, we have used its board for also for using our base. So these are the connections. The connections are same as we have designed our PCB in Proteus. So as I discussed in the schematic and PCB, that sensors will be in the front, and the NOT, the OR NOT and end ICs will be connected, and this is basically the voltage regulator. This is the voltage regulator. This is a connection for a base for the cells we will connect. This is basically the front at that tie that will ensure the taking the turn by the robot. This is basically the overall design of 3D design of our robot. So here we have a line follower robot circuit. Um, First of all, we will see which sensor is which one. This is the rightmost sensor, right sensor, left sensor. These both are the center sensors. So we'll name it center 1 and center 2 sensor. Okay. Now this is the main voltage regulator, which will convert this 9 volt 7.5 volt or something like that to 5 volt. So the three ICs we have are a NOT gate IC. We have used 4 NOT gates from this IC, and this is an AND gate IC, and similarly we are using 4 AND gates and OR gate IC, and we will be using 2 ICs, and the OR gate ICs are basically 3 input ICs. So now we'll see how it implements the logic of our robot of a line follower robot circuit. So one thing that we have left is these LEDs. The LEDs which we have connected are representing the motors will be using in a line follower robot, and this one is the right the this one is representing the right motor, and this one is representing the left motor. Now the logic is that if there is if they are following, if there is no black line, then they should be on. So they are moving forward, the motors are on. And if the so the logic is that if these sensors are sensing a white surface, then the motors are on. Okay. Similar case is then when both the left and right most sensors are sensing white surface, and the center sensors are sensing black line, then still they will be moving forward. But if the left side 2 sensors are sensing a black, then there must be the left sensor must turn off, and the right sensors must be on, so that it takes a turn. Similarly, if 3 left sensors are off, then this must give a left motor off.
Alternatively, when the right sensor is sensing a black line, then the right sensor must turn off and the left sensor must left motor must be on so that it takes a turn. Similar cases are two right sensors and all three right sensors. If the last point comes and when all the sensors will sense a black line, then this must the motors must turn off and the robot should stop. So these two sensors must turn off. So if all the sensors sense a black line, then this is the case. So that is it.
So the final stage is testing. Testing, we have ran the robot on a black line, and as it completed a full lap, so this confirms it's working. So thanks for watching the video. Allah Hafiz.